My name is Alex Cayco Gajic. I'm a junior professor at the Group for Neural Theory at École Normale Supérieure in Paris. And the project that I will be doing for my for ICA 4 this year is called From Movement to Cognition, Understanding Cerebello-Cortical Coordination for Flexible Learning. My realm of research is in computational and systems neuroscience, focusing on the cerebellum, which is a region that is classically thought to be implicated in motor control and in particular motor adaptation. So the textbook view, as I show in the first panel on the left, is that the cerebellum is thought to adapt movements to new sensorimotor contexts. And the example that I'm giving here is someone who learns to ski on piste and then needs to learn later to perform exactly the same movements, but this time in deep powder. So the cerebellum is really thought to be involved in this kind of adaptation of movement and motor control. However, there's been emerging evidence over the past decade that the cerebellum is also involved in cognition. This includes working memory, decision-making, and even in normal social behaviors. And this has been found in fMRI studies in humans and also in systems neuroscience studies with calcium imaging and optogenetics in mice. So there's also some anatomical reasons to believe that the cerebellum is involved in these more cognitive functions. It forms loops with the majority of the neocortex, including motor cortex, of course, but also including the prefrontal cortex, which is a region that's involved in these higher order cognition and executive function. And because the cerebellar architecture is so regular across the cerebellum, that means regular, so it's similar architecture both in the areas that are forming loops with the motor neocortex and also the part that is the areas that are forming loops with the cognitive neocortex. Because of this, there's some hope that maybe we can understand what the cerebellum is doing with the prefrontal cortex by understanding how it works with the motor cortex, basically. For my project, I'm interested in trying to tackle these two open questions together at the same time. So the first open question being, how does the cerebellum coordinate with any part of the neocortex, with the motor cortex, for example? How does the cerebellum and the motor cortex coordinate to produce and adapt motor representations and populations of neurons? That's the first open question. The second open question is how is the cerebellum involved in these cognitive functions at a circuit level? Because so far the ideas that we have in this field are quite nebulous. And I propose to take both of these questions forward by at the same time by modeling the cerebellum's role in cognition using recurrent neural networks. Recurrent neural networks, or RNNs, are a technique from machine learning that's gaining traction in computational neuroscience. And it basically subverts the traditional way of doing computational neuroscience. So instead of building bottom-up networks and then seeing what they can do, with RNNs, we take a randomly connected network and we train them to perform some particular task. And then we see how the network was able to accomplish this, both at the structural level and also at the level of the kind of latent neural representations that are encoded in the activity of the population of neurons. So what I want to do is to extend traditional RNNs that are modeling one particular area to a cerebello-cortical RNN, so a modular RNN that has a randomly connected module that is analogous to the neocortex, and a highly structured module that's analogous to the cerebellum. Train it to perform different motor and cognitive tasks and see how cerebellar adaptation changes the task performance of the model, as well as the representation of different movements or cognitive tasks. Thank you.